An encapsulated sphere. An object surrounded by a translucent material with index of refraction greater than unity appears enlarged. This includes items such as plants or shells inside plastic or resin paperweights, as well as ancient bugs trapped in amber. Consider a spherical object in air with radius r fixed at the center of a sphere with radius capital R greater than r with refractive index n as shown in the figure. So this has radius capital R greater than radius r. So this has index of refraction n. When viewed from outside, the spherical object appears to have radius r prime that is greater than r. Using right triangles found in the figure, write an expression for sine theta a in terms of r and capital R. What is theta a? So theta a is the angle this beam makes from the top of this object with respect to the central axis. Part B, similarly write an expression for sine theta b in terms of r prime and r, where theta b is the angle the central axis makes with the emerging beam. Part C, using Snell's law, derive an expression for r prime in terms of r, capital R and n. Part D, if the object is a spherical Dandelian seed head with diameter 45 meters fixed at the center of a solidified resin sphere with radius 80 millimeters and index of refraction 1.53, what diameter will the seed head appear to have when viewed from outside? So let's start with part A. So we have this triangle OAB, so that's basically consisting of the beam that is coming from the top point A of the spherical object and the central axis R, and the angle we have here is theta A. So this OAB right triangle tells us what the sine of theta A should be. So sine of theta sub A, as we can see from this right triangle, is r divided by capital R. So that is r divided by capital R. Now we were asked to find sine theta in terms of r and capital R, so this task is achieved for part A. Now going to part B, I want to write sine theta b in terms of r prime and capital R. Now let's concentrate on this right triangle, OBC triangle. So you can see that this is the central axis and this is the basically direction, the axis that is parallel to the emerging beam. So this angle theta b is the same as this angle theta b. From OBC triangle, I can read sine theta b to be r prime, the radius of the object appearing to be r prime from outside, divided by capital R. So OBC triangle, sine of theta sub b is equal to r prime divided by capital R. Part C, using Snell's law, derive an expression for r prime. Now, if I look at the angle of incidence for this beam with respect to the normal to the surface, that is theta A, and the angle of refraction is theta B. So we have n sine theta A, Snell's law, is equal to, because the outside is air, here, the index of refraction we can take to be 1 sine theta sub b. That's basically Snell's law of refraction. And For sine theta A, we have r divided by capital R. And for sine theta B, we have r prime divided by capital R. So we can see that n times r divided by capital R sine theta A is equal to 1 times r prime divided by capital R sine theta B. R capital R's will cancel, and we will find that the radius that appears from outside is the index of refraction n times the actual radius of the sphere R. So in part D, we have the diameter of the object to be 45 millimeters. If the object is fixed at the center with diameter 45 millimeters, therefore its radius is 45 divided by 2, 22.5 millimeters. The index of refraction n is 1.53, therefore the radius r prime will be 1.53 times 22.5 millimeters, and the diameter of the object will be d prime 2r prime. So it will appear to have this diameter that will be equal to 45 times 1.53, and we will find the diameter 68.8 millimeters when viewed from outside the resin. Okay, so we have an encapsulated sphere that is surrounded by a material with index of refraction n greater than unity. Now this sphere, when viewed from outside, appears to be larger. So it has a larger diameter and larger radius. So using right triangles, using this triangle here, we can write sine theta A is r divided by capital R. And since theta B is also this angle here, sine theta B is equal to r prime divided by capital R. So those are parts A and B. And writing Snell's law, n sine theta A, the angle we make with the normal, is air index of refraction 1 sine theta B. So for sine theta A, we substitute r divided by capital R, sine theta B, r prime divided by capital R. We find that r prime is indeed larger than r by a factor n, index of refraction. And if we have an object with diameter, spherical object with diameter 45 millimeters at the center, it's going to have a diameter n times the diameter, so n times 45, 1.53 times 45, 68.8 millimeters when viewed from outside.